Let's go back to January 28th, 1986. America was just captivated. This was a huge deal. NASA was about to send a teacher, Krista McAuliffe, into space. Kids all across the country were watching live in their classrooms as the Space Shuttle Challenger just soared into the sky. And for 73 seconds, well, it was perfect. A symbol of everything we could achieve. And then, just like that, it was all gone.
We've all seen that image, right? That haunting, Y-shaped cloud burned into our collective memory. The official story, the one we all heard, was that there was this catastrophic, instantaneous explosion. But you know what? That's not the whole story. It's not even close. What investigators eventually found, deep down on the ocean floor, paints a picture that is so much more terrifying.
You see, the chain of events that doomed the Challenger didn't actually start at liftoff. No. To understand it, we have to go back to the night before. It all started in this incredibly tense conference call. A call between NASA managers and the very engineers who built the shuttle's rocket boosters. This is where the real countdown began. 18 degrees Fahrenheit, that's -8 Celsius, in Florida. Let that sink in. The launch tower itself was literally covered in icicles. This wasn't just a chilly morning, it was completely unheard of for a launch. And that one number, that temperature, was the single most critical factor in what was about to happen. So on that call, the engineers from Morton Thiokol were practically begging NASA not to launch. And this wasn't just a hunch. They had the data. They knew that these crucial rubber seals, these O-rings inside the rocket boosters, would get stiff and lose their flexibility in that kind of cold. They'd become brittle, and they wouldn't be able to seal the joints properly. It was just simple, undeniable physics. And this was the response they got. Can you just feel the tension? The engineers are laying out this dire, science-based warning, and a NASA manager who was under this immense pressure to keep the launch schedule on track just hits back with this. It just perfectly captures how the engineers' very real safety concerns were just brushed aside. That night, management made the call. They overruled their own experts, and they gave the green light to launch. And with that one fateful decision, the 73-second flight of the Challenger was pretty much set in stone. It wasn't an accident waiting to happen anymore. It was an inevitability. A catastrophic failure was now locked in. So what is this O-ring that they were so worried about? Well, honestly, it's not some super complicated piece of technology. Think of it like a simple washer you'd find in a garden hose, just way more heavy duty. It's a circle of rubber, but its job was to contain pressurized gas burning at over 5,000 degrees Fahrenheit inside those gigantic rocket boosters. So yeah, a really simple part doing a life-or-death, mission-critical job. This timeline is just chilling to read. Okay, so less than 1 second after ignition, there it is, a puff of black smoke. That's the cold, brittle O-ring failing exactly like the engineers said it would. But then something absolutely bizarre happens. A byproduct from the burning fuel, the stuff called aluminum oxide, actually plugged the hole. It was this strange stroke of luck. For nearly a full minute, they were flying on this fragile, accidental patch. But at 58 seconds, the shuttle slams into a blast of wind shear. The whole structure flexes, that temporary plug gets knocked loose, and a blowtorch of flame starts burning its way out. Now, this is a really crucial point. There was no explosion in the way we think of a bomb going off. It wasn't like that. Instead, that jet of flame coming out of the booster created these insane aerodynamic forces that just ripped the shuttle apart. And here is the single most important and terrifying fact of this whole story. The crew cabin, which was heavily reinforced, broke away from all that chaos completely intact. And this is where the story takes its darkest turn. For a long time, the public was allowed to believe that the crew died instantly in that fireball. But the evidence that was eventually pulled from the bottom of the Atlantic Ocean told a completely different and, frankly, a much more harrowing story. So after breaking away from the rest of the shuttle at around 46,000 feet, the cabin's momentum just kept carrying it upward. Think about that. It continued to arc through the sky, reaching a peak altitude of 65,000 feet. That's over 12 miles high, before gravity finally took hold and it began its long fall back to Earth. Down in the wreckage, investigators found the crew's emergency air packs. They were called PEEPs, and when they examined them, they made a absolutely stunning discovery. 3 of the 7 packs had been manually switched on. Now, this is not something that could have happened by accident during the breakup or on impact with the water. No, someone had to physically flip those switches. And here is the undeniable, heartbreaking proof that they were conscious. The switch to activate the pilot Mike Smith's air pack was located on the back of his chair. There was no way he could have reached it himself while strapped in. This means that in those chaotic moments after the breakup, as the cabin was tumbling through the sky, another crew member had the presence of mind to act. They likely unstrapped, reached over, and turned on his air supply for him. They were alive, they were aware, and they were trying to save each other. 2 minutes and 45 seconds. Just let that number hang in the air for a moment. That's how long they estimated it took for the crew cabin to fall from the top of its arc all the way down to the surface of the Atlantic, where it would hit at over 200 miles per hour. The impact with the water is what ultimately killed them. So in the aftermath, this big commission was formed to investigate what happened. And NASA management came in with all these complex charts, trying to kind of muddy the waters with bureaucracy and jargon. But one member of that commission, the brilliant physicist Richard Feynman, was just not having any of it. He was not going to be fooled. So, getting tired of the runaround, Feynman did something so simple and so brilliant, right in the middle of a live, televised hearing. He got a little piece of the O-ring rubber, he squeezed it shut in a C-clamp, and then he just dunked it into his glass of ice water right there at the table. After a few seconds, he pulled it out and released the clamp, and the rubber, it didn't spring back, it just stayed compressed. In 10 seconds, he showed the entire world the simple, fatal flaw that doomed the shuttle. And this was Feynman's ultimate conclusion, and it's the real lesson of the Challenger disaster. This wasn't just about a technical failure of a rubber ring. It was a human failure. It was the failure of an organization to listen to its own experts, a failure to put reality and science ahead of PR and launch schedules. It's just this haunting reminder that you can't argue with the laws of physics, because, as Feynman so perfectly put it, nature